Hi everyone, Mr. Ball here, and this is our geography topic about volcanoes and earthquakes. This is lesson 2, and on this slide we're just having a quick look back at what we did in lesson 1. If you managed to send me photographs of what you've done last time, well done, that's fantastic. And even if you didn't manage to get any Play-Doh, don't worry about it. You need to know these things though. These are the things we need to remember, that inside the earth and how its layers work. First in the middle is this very hot core of iron. Then you've got the outer core, which is mainly iron and nickel, also very hot. And finally the mantle. And this area is where the rock, it's so hot still that the rock that's in there is melted, molten rock, and we call that magma. And as you know, sometimes it breaks through the crust, and that's when you get volcanoes. And so the crust is the actually relatively thin part that we live on. Here we are on the top, and so that's what we need to know from lesson 1. Moving on now to lesson 2. In lesson 2 we're looking at this question: what are tectonic plates? So here's a great example of how you can see, sometimes you can see how the tectonic plates actually affect the landscape. And this is a great photograph of in a place in Iceland. And we should just point out that that's Iceland the country, not Iceland the supermarket. Moving on, this is the effect, some of the effects of the movements of tectonic plates. So here, as you can see, is a photograph of a city nearly destroyed by the effect of an earthquake. The buildings have all fallen down. People still, most of them seem to be alive, but obviously it can cause death and destruction, especially if it's an area where lots of people live in and there are cities nearby. And we're going to talk about that later. So one of the big effects of the movements of tectonic plates is earthquakes. Second big effect is volcanoes. And when tectonic plates move next to each other, or crash into each other, or sometimes when they move apart from each other, you can this affects creates volcanoes. And so this again can be very destructive. People living nearby, nowadays we tend to have some warning that there might be a volcano about to erupt, and then people can leave. They might lose their house, they might lose everything, but at least they're still alive. But of course in the old days, as you know, like in places like Pompeii, they didn't know that it was definitely going to be, the volcano was going to erupt and lots of people would die. Again, it can be very dangerous if it happens near big centres of population. Third effect, if you have an earthquake that's under the ocean, then the knock-on effect of that can be what we call a tsunami. Old-fashioned name for this is a tidal wave. Here's a picture. This is actually very recent. This is in 2011, so it's only 9 years ago, and it's in Japan. You can see it's in Japan by the signs here with the Japanese writing. And obviously this one was very dangerous, so lots of people did get killed. It happened on the north coast of Japan, and loads and loads of things destroyed. You can see cars being sort of pulled along and floating along down the road. So earthquakes, volcanoes, tsunamis, all effects of the movements of tectonic plates. Here's a picture. This one of these rescue guys, he's there working to see if he can, I think he's actually looking to see if anybody is under there, and he can hopefully get them out in the devastation of an earthquake. And then this is the sort of effect that can happen as you look, the road is basically been ripped up. So if that's the effects of tectonic plates. Now what are they? So for today I want you to think about, imagine the earth as being a bit like a hard-boiled egg. And here's a photo of a hard-boiled egg. And when you start tapping the shell of an egg, you'll see the shell is not totally solid, and it breaks up into these, and this is like the plates that we have on Earth. So the crust is actually not a totally solid crust, and it has these little gaps, tiny cracks between the tectonic plates. Okay, and so here is a diagram showing a map of the world. Here's where we live in the UK, and these are the divisions between all the main tectonic plates. And as you probably can see, all of the continents are on a tectonic plate. So for example, this is the African plate. Okay, and then here's the Eurasian plate, and here's North America, South America, etc. It's not quite as simple as that, because there are other plates for example, India and Arabia. And I'm sure you probably already know that here between India and Asia, right there along that boundary, is where the highest mountains in the world are, including Mount Everest, in a mountain range called the Himalayas. And that mountain range has actually been caused by this plate, the Indian plate, pushing up, and this plate, the Eurasian plate, pushing down. And they have, over many, many thousands and thousands of years, been crashing into each other and pushing together, and this forms the mountains. And that's why they have the high, very, very high mountains there. In fact, the Himalayas are still growing a little bit every year. Now, the tectonic plates fit together a bit like a puzzle. So if you think back to the egg, the surface of the egg, it's a bit like that. And along the edges between the two plates is where most of the action happens, to do with earthquakes, volcanoes and tsunamis. So, for example, up here is Japan, okay, and that's where I mentioned about the tsunami that we saw a picture of earlier. And then the city that we saw a picture of, where they'd had lots of buildings knocked down, that's over here on the edge of this tectonic plate, where North America meets the Pacific plate. So that's tectonic plates. And as we mentioned before, we just need to remember that underneath the crust is the thick, soft, hot, flowing rock, which we call the mantle. And that's how they're able to move around, because they're moving, they're basically floating on the top of this mantle. Now, the tectonic plates have been moving around for millions of years. They don't move very fast, and you would never be able to tell that the tectonic plate that we're on is actually moving. And our tectonic plate is actually gradually moving away from America, very, very slightly every year. And in the past, the tectonic plates, millions of years ago, all were in different places. And it looks like scientists think that the different continents actually would, in the past, have been joined together. And here's how South America would fit into right next to Africa. And if you look at that on a map, you could see how, although they're not connected nowadays and there's a big ocean in between them, they look as if they could fit together, and scientists think that they were. And they can prove it because they've found very similar types of rocks in both places, and similar fossils of creatures that lived in both places. Here's a map of the ancient, the way the continents used to be millions of years ago, which is a big giant continent, which is called Pangaea. Okay, so Pangaea is this continent where they were all either very close or actually linked together. Now, here's a challenge for you. So if you're at home watching this, you're going to pause the video, and then you're going to see in a minute when I've finished, and you're going to see if you can work out what all these continents are. Try and recognize them by their shape. There's one that isn't a modern continent, and it's this one. This is India. And as we mentioned before, that's a separate plate. Okay, but the others are the continents that we know about. Okay, because we know a song and a way to remember them all. But which is which? Okay, so you pause the video and see if you can. But you don't need to write anything down for me, but just make a list, because they've all got numbers on them, and you can see if you can work out which is which. Okay, so you're gonna pause it, and then I'm gonna move on. Right. So here's the answer. Now, that was quite a hard one to spot, Eurasia, but I think you would have noticed the shape of Africa, and we already mentioned how it used to fit in like a puzzle to South America. That's North America. India, I mentioned before, is not one of the modern continents. It's not separate anymore. There's Australia and there's Antarctica. But now they've spread out, and as you can see, this ocean now is between Eurasia here, Africa there, and on the other side of the Atlantic Ocean is North America and South America. Okay. Now, around the Pacific Ocean, the Pacific plate in the recent times, in the times that we know about, as in the last couple of thousand years when we have written records of things, this has been by far the most active region where the tectonic plates movement has created volcanoes, earthquakes and tsunamis. Okay, so we're lucky we don't get to them in Britain so much. We can talk later about how the closest place to us where they have a lot of volcanoes is Iceland. We'll talk about that later, but around the edge of the Pacific, where it bashes up against the North American plate and the Indo-Australian plate and the Eurasian plate and the South American plate, that's where the vast majority of the world's earthquakes and volcanoes happen. And this area is called the Ring of Fire. Okay, as you can see, it's not quite a ring shape, but it's a good way of remembering that that's the area in the world where they do get the most volcanoes and earthquakes. Here's an example of plate tectonics. So here's a picture of Iceland, and these plates are moving apart from each other. And you might think that's going to cause less damage than when they bash into each other, but actually it can still cause a lot of volcanoes and earthquakes. So this plate is moving that way, this plate's moving that way, and to see it on a big diagram, Iceland is where the North American plate meets the Eurasian plate. Okay, and when they move apart, you get volcanoes, and there are lots and lots of volcanoes on the Iceland. In fact, Iceland wouldn't even be there if it wasn't for the tectonic plates and the activity. When they move apart, the magma gets forced up through the crust, and then it erupts, and it can erupt under the ocean, but it gradually has been erupting and erupting under the ocean until it's built the island of Iceland. So there are three ways, and I want you to learn this today, so this is something that you're going to be doing some work on in a minute. There are three ways in which the tectonic plates can meet. Okay, so the first example is when they pull apart. Okay, so here is the mantle. Here's the North American plate we talked about and the Eurasian plate, and they're pulling apart. And it's still happening, it's happening all the time. And when they pull apart, you get the mantle will be forced up sometimes through the crust, and it builds like a ridge which scientists can see, and you can see this in the Atlantic. It's called the Mid-Atlantic Ridge, and this magma is then forced up, and you get volcanoes and sometimes earthquakes as well along that line, along the line of the tectonic plate. So the key word I want you to learn is divergent. So we're learning this, what a tectonic plate is. One way in which they move is they split apart, and that we call that divergent. The second way that tectonic plates move is they can push together. When they push together, one of them will be forced underneath, and you'll get a lot of activity here along the line, and you can create, if two of these push together in the right way, it can create mountains. And here's the example: the Himalayan mountains, including Mount Everest, the highest mountain in the world. This is how they have been created over many thousands and thousands of years. Sorry, should have said the key word for this type of movement is convergent. So the first one is divergent and the second one is convergent. They push together. And the third way they can create volcanoes, earthquakes and tsunamis is when they slide alongside. So they might slide in opposite directions, and then sometimes they can get caught underground, as the rock up here can be very brittle and it'll get stuck, and that builds up a lot of pressure, and then suddenly it'll move and you get an earthquake. Even if the plates are moving in the same direction, which they might be, but if they're moving at different speeds, then it'll still cause tremors and cause earthquakes and possibly volcanoes. This type of movement is called transform. So the three types of movement are divergent, convergent, transform, and I want you to learn those words and what they mean. Here's the example. This example is these guys have come along and they've noticed a crack in the road. Of course, that crack in the road's not too bad, and you could probably just drive your truck over that, but if that means there's another big earthquake to come, you probably need to evacuate any towns and cities, because the buildings will fall on people and it could be horrible. And again, that's on the west coast of the United States, as part of this Ring of Fire. Right, so these are the tasks I want you to do. for your geography for me for this lesson. Task 1, this will be on your on our Teams page, this sheet, and you're going to have your own version of it. You can either print it, but don't worry if your printer's not working, don't worry about it. Just draw something similar, okay? Then you're going to colour it in. Okay, obviously you can work out what colour this rock will be just under the earth. Here's the crust, here's the sea. Okay, and you can use your, I'm sure you can work out what colours to do things. So these are the two plates. This is the sea. You can imagine this is the Pacific plate moving alongside the North American plate. And here you've got mountains, maybe like in the Himalayas. So you're going to colour them in, put the right label for each one. Remember the key words are divergent, convergent and transform. You're going to decide which is which, colour them in, and when you've done that, can you do also, on a separate piece of paper, write a paragraph explaining each diagram, and then you can send all that to me and I'll send you some feedback, okay? And when you come back to school, we can put it all in your geography book. Okay, well done, that's great, and I look forward to seeing you soon. All the best.